Hello and welcome to the third Positive Thinking webcast. My name's Kevin Boris. I am the editor of Thinking Highways magazine, who produced this lovely webcast. Now, the reason we call it a webcast and not webinar, in case anyone's wondering, is because I hate the word webinar. There's no other reason. If you want to refer to it as a webinar, you may do so. I just don't. Anyway, so thank you for joining us. We've got over 150 people on, which is great news. Thanks for your time. Now, you need to know who's actually going to be on the program. First of all, we have our regular panellist, Mr. Bob McQueen. Hello, Bob.
Oh, hi, token Scotsman and general all-round smart Alec here.
Yes, I didn't want to say that, Bob, but yes, you have written your own intro, so that's great. We have our other panellists. We have, I refer to this man as the godfather of RTS. He doesn't like that because it kind of refers that he's older than he actually is. But Phil Tarnoff, thanks for coming, Phil.
Pleasure to be here.
And I apologise for that.
I prefer not to be thought of as a godfather. It implies huge, long age.
It does, but I'm doing it in terms of reverence, but so that's fine. And we also have from Econolite, we have Gertej Gill. Hi, Gertej.
Hi, how you guys doing?
And just want to make sure that everyone realises that Gertej prefers to be referred to as Gill. So I'm not being rude and just calling him by his surname. So we'll refer to you as Gill from now on. Is that correct?
Sounds good to me. It's easier for everyone.
Fine. That's great. Excellent. So that's Gill. We also have from DKS Associates, we have Kevin Fayon. Hi, Kevin.
Hi, glad to be here.
Thank you. And hopefully, a little later on, we'll have Don Mass from Peak. Unfortunately, people find it very amusing when people who work in the traffic industry are caught in traffic. But Kevin is apparently on his way back to his desk, and he shall be joining the conference very shortly. Now, you as attendees, you'll be listening to the presentation, but you can join in. There's a question option that should have come up on your screen now. You can key in questions, type questions out throughout the program. If they need urgent addressing, I'll butt in and I'll ask the questions for you. Otherwise, we'll have the questions at the end. Now, as there's two of us on here are called Kevin, if you want to address a question to Kevin Fayon, please put Kevin F as the person you want to ask the question to. Otherwise, I'll think it's for me, and I probably won't know the answer. And also, I'll read the questions out during the presentation if it's so required. And also, note we have someone from India on the panel, someone from Australia, and someone from England. We may mention cricket at some point. So all of you who are based in the US and have no interest in cricket, which I presume is virtually all of you, I apologise for that. But India are currently playing Australia. So Gill and Kevin may discuss this at some point. I shan't mention who's doing the better at the moment, but it's not Australia. Okay, so I think... sorry, it's not. I'm not gloating, but we had the worst cricket team in the world for several years, and we don't anymore. We've now got the second best.
Yes,
so,
yes, you are gloating, yeah.
No, it's not. Scotland, who are currently not a test-paying nation, Bob, but one day Scotland will be a well, we know this. Anyway, so,
Kevin, we have 11 people in Scotland that play cricket.
Well, you have a team. You did actually. You beat the Netherlands once. Hey, come on! It's just, I'm not judging anyone.
There we go.
So welcome to the webinar or the webcast. I'm doing it now. Welcome to the webcast or web conference. You won't hear from me again until the questions. I shall now keep quiet and hand over to Bob McQueen. All yours, Bob.
Thank you very much, Kevin. So my first job, I think, is to offer a little competition to the panelists. A to-be-revealed prize will go to the panelist that can say webinar the largest number of times in the presentation. Just kidding. But
may I just say
and then Kevin will give.
There is no prize. Thank you.
And Kevin, we will find a prize for you if you avoid talking about cricket for the next 60 minutes.
I avoid it for 11 months of the year, so it's fine. I shall not mention it again. Thank you.
Well, welcome everybody. The subject today is adaptive traffic signal control, and I believe we actually have a slide that one of the panelists has put together that defines what we mean by adaptive, which is pretty good. And I think that we have a series of talking points, which should now be on your screen. The first talking point is what do we mean by the term adaptive. And we also want to explore the fact that the benefits are seemingly well understood, so why are we not further ahead? And how does adaptive stack up with transit and emergency vehicle preemption, and do we need a standard for adaptive signal control? And as the future looms ahead of us here with the connected vehicle, how do we deal with the signal, phase, and timing message? What's holding video back? Are we getting the benefits that we expect? Why can't we have wireless connections? And then, my favorite subject is, do we really need all this heavy-duty current, or can we have battery-operated DC traffic signals? And is it time for a rethink on traffic signals all around? Those are some of the talking points, and I'm getting between you and the panelists. So without further ado, we'll move on to the first panelist. Kevin, are you doing the introduction? Kevin's gone.
I hadn't planned on it. No, I was still
Oh,
thinking
okay.
of how I can mention cricket again. No,
Oh,
I
I
think
wondered what you were thinking about. Yeah.
sorry. No, I
Yes,
pressed the mute button. I couldn't
yes.
unmute myself, which is a great thing. My wife would love that. If I had a mute button.
Oh,
No, I
that's
think
wonderful, yeah.
our first speaker is Mr. Piltanov. So, Gareth, if you'd like to press the
needs-
button, it's all
It
over
needs
you.
no introduction. Yeah.
I don't think he does. I think it really does need an introduction other than saying his name, which is only fair.
Well,
Phil.
that's comforting because I had no idea how you were going to introduce me. I worry about that. Those of you in the audience,
Well, I could
those-
never I feel like I'd never, under any circumstances, say anything bad about you because you were the first person I worked for when I came into the U.S. in 1994.
I taught Bob everything he knows. God help us. Yeah,
Exactly. So it's all you. So it's all your fault.
Excellent.
that's right. And those of you who are listening in will be pleased to know that I have no intention whatsoever to talk about cricket, kind of a ridiculous game in the opinion of most Americans. And, you'll also be pleased to know that I'm going to be speaking in American as opposed to English, so that you'll probably be able to understand me a lot better. I thought I'd start off by, as promised by Bob McQueen, if we go to the next slide, please, Kevin, or Gareth, I guess, by offering a definition of adaptive control. There's no magic in this, but I'll just quickly read it. Adaptive control is a form of traffic signal operation in which phase times of a signal system are continuously adjusted to optimize an objective function. And you notice that at the note at the bottom, stay away from the term timing plan, which is a stored plan. We'll talk about that. And I avoid using the term real time because that always incites a great argument as to what is real time, and you never defined it and so forth. So I thought it would be useful not to talk about that. But more importantly, the term cycle split and offset are not in there because there are forms of adaptive control that don't adhere to a fixed cycle length for every cycle, if you will. But the green times are just continuously adjusted on the various phases. So that's my definition. Take it or leave it. And I think it's important to realize that we're not only minimizing stops and delays, but there are systems that maximize person throughput, and those are the systems that tend to favor transit operations. So moving right along, I'd like to get to the next slide. A question that I think is going to be one of the key discussion points of this particular session, which is why isn't every city in the United States using adaptive control? And I've put together a list here. We could argue about it, but I think the list is generally recognized as being true. And the first bullet is probably and it's the one I want to talk about in the subsequent slides. But the question that many American traffic engineers, in my experience, ask is, are the benefits high enough and visible enough to be worth the extra cost of the system and all of the complexity that comes along with it? There's no question about, well, we need additional surveillance if we're going to be calculating signal timing online on a continuous way. And it's the old axiom, garbage in, garbage out. If we don't have adequate surveillance, the timing plans that we get are just going to be garbage. Now, there's one item that's missing from this list that I thought about this morning, and I wish I'd put it on there. And that is one of the disadvantages that many of the systems in the United States suffer from is the fact that their architecture, I hate that term because it's been messed up by subsequent studies, but their architecture is other than that of a centralized system, which are the types of systems that are best suited to adaptive control. There are many closed-loop systems in the United States, and I think most of you know what that is, but I'll define it for those of you that don't. A closed-loop system is basically a three-level system that includes local traffic signal controllers, local area masters, and a central computer. And the presence of the local area masters really is incompatible with the manner in which the software has been implemented for a lot of adaptive systems. So people that have closed-loop systems are sometimes faced with some major reconfiguration of their systems, and I think that's responsible for, in part, for one of the reasons that adaptive control is not accepted that readily in the United States. But I do want to talk about the benefits, and that's what I'm going to spend much of the rest of my copious 5-minute time speaking about. So we go to the next slide. I think one of the big issues, and I've run into this many times when I've been involved in the implementation of adaptive systems, is that we don't understand the conditions under which they shine. An adaptive system is not designed to necessarily, or will not necessarily shine with normal morning peak, off-peak, PM peak traffic flows that is characteristic of many normal weekday times. And I've found that a lot of people install an adaptive system, and the first thing they do is they compare the performance of the system with their time of day system by measuring its performance during a typical morning rush hour, typical evening rush hour. And lo and behold, the performance is marginally better or maybe even worse than it was for their time of day system, which has been fine-tuned over many years and many hours of efforts going into making sure it works as well as possible. Where the adaptive control does best is under conditions, unpredictable traffic flow conditions. If there's an incident on a parallel freeway, or there's a facility such as I used the example of business and university that has schedules that change irregularly, or shopping centers with sales, holiday sales. Those are the conditions under which adaptive control tends to shine, and those are the conditions that are rarely used to compare the performance of the adaptive system with the time of day system, and as a result, we consistently get what I would characterize as the wrong answer. There are also many areas in which adaptive control will shine when we're talking about traffic conditions that change more than the available plans. In other words, I call it the shoulders of the peak period, moving up into the peak. Adaptive control can provide response to that in a continuing basis. But again, the evaluations are typically done during the normal rush hour times a day, and that's when you're not going to get necessarily stupendous results. I've tried to characterize that on the next slide. This is a slide some of you may have actually seen before. I've used this in some of the courses that I've taught on this subject, is that adaptive systems, if they're kept up to date, and that's another issue, by the way, but if they're kept up to date, will generally show fairly consistent performance. What I characterize as a first-generation system on this slide, you can substitute the word time of day system for first generation. The performance of those systems will oftentimes be much better than the adaptive system because, as I said before, there's many hours of traffic engineering and field adjustments and things like that that have gone into making that first-generation system a first-class system. But as time goes on, many agencies, and I think the number is about somewhere in the vicinity of about 35 or 40% of the agencies in the United States, never retime their signal systems, and so the quality of the signal timing decays relative to the demand that's on the street over time as traffic patterns change, and that first-generation system is not updated. And so the adaptive system continues to respond to what it's measuring, while the first-generation system performance deteriorates over that time. So this is another area in which adaptive control will outperform first-generation systems. Unfortunately, when the comparisons are made, it's made during that first year or two of the system installation, and as a result, you don't see those benefits. Moving on to the next slide. In the interest of time, we could talk about this for hours, obviously, but I'm not here in luck. I wanted to look into the future a little bit, and this gets back to the question that Bob asked about the connected vehicle. A connected vehicle is nothing more than a probe-type system. In other words, the connected vehicle system, if it ever exists, will be providing data that's very similar to other probe-type data sources. And I see on my slide I've really, well, no, I haven't. Never mind. I'll retract what I was about to say. But there are many different types of probe data sources. The connected vehicle, when it exists, Bluetooth data, traffic monitoring is a form of probe data. Toll tag traffic monitoring is a form of probe data. And these data sources, I personally think, offer significant potential for improving the performance of adaptive control systems. And I say that because one of the shortcomings of our conventional detectorized systems is that they aren't capable of measuring queue lengths, and they really don't measure demand appropriately. They measure free-flow speeds, and they measure, to a certain extent, stop time, to a certain extent, but they really don't give you the whole picture. They're basically point samples, whereas the probe is giving you data, giving you an idea of what traffic flow is over the duration of the link that's approaching the intersection. So in order to use this, though, we're going to have to modify these algorithms to take into account this, what I view as superior data. But I think at the end of the day, we're going to end up with better systems that will be installed at lower costs. And with that, I'm going to, I think I've talked long enough, maybe too long, and turn the floor back to whoever's moderating.
Okay, thank you very much, Phil. Some interesting points there, as usual. We'll keep the questions to the end and move on to the next panelist. Kevin, you want to introduce the next panelist?
Okay, I will. Yes. Now, the next panelist is Gurtej Gill from Econolite. Gurtej wrote an excellent piece for the last edition of Thinking Highways North America. Hopefully you've all had that. If not, do go and have a look. thinkinghighways.com, click on the publications, and then on North American, the latest issue, which is the December-January issue, and have a look at Gurtej's article. Excellent stuff. That's why he's here, because I invited him because of that. So, Gurtej is going to be talking about how does adaptive make a difference.
I thought you were going to call him Gill.
I know. I'm sorry. It just sounds like public school where you call them by their surname. But thank you, McQueen.
Most convenient for you guys.
Okay.
Come on, Boris. Get on with it, Boris.
McQueen, this is going to sound great on the recording, isn't it? Excellent. Okay, Gurtej, it's over to you, sir. Thank you.
Hello? All right.
Okay, it's all yours. Gurtej.
Sorry.
Yep.
We've handed the floor over to you.
Awesome. Okay, so I think Philip hit the nail right on the head there, where he was talking about how agencies may not see the benefit of an adaptive system over a first-generation system, and the graph he showed I thought was very interesting because I have one that's very similar here. So it's how does adaptive make a difference? And I'm clicking and it's not letting me. There we go. Okay, so if we look at traffic signal performance over time, we have say a traffic signal system in our arterial will operate between two extremes. We have an optimal level of performance and an unacceptable level of performance at which the signal system will need to be retimed, correct? So if we look at maybe today and we have a system that just recently timed, it's going to be operating optimally. But over time, the signal system will degrade just by normal fluctuations in traffic flow, say, increase in traffic volume, change in origin-destination pairs, until it's degraded so far we've reached an unacceptable level of performance, at which time the agency will typically retime their system back up to optimal. But then the same thing kind of happens again, and then we get back down to the unacceptable level of performance at which the system's retimed and goes back up to optimal again. So the benefit of adaptive technology is we don't need to wait, sometimes the 3 to 5 to, as I've heard, as long as 8 to 10 years before to re-optimize the signal system, when we can have an adaptive technology polling the intersections and adjusting to real time, adjusting the traffic flows as they arrive. So those instant conditions or those unpredictable traffic flows, as Philip was mentioning. So I tried clicking here and going to the next slide. Seems like we have a little bit of lag.
Gertage, it's just
Yep,
Gareth here. I'm controlling the slides, so if you just tell me when to move them, I'll move them on for you.
Okay, all right, sure.
Okay.
So yeah, so here we have a
Okay, so it's all Gareth's fault then. Yep.
I was
Apologies.
trying to figure out what was going on. I couldn't tell if it was on a timer or not. But you did fairly well there, Gareth.
Thank you.
So we created a Vism simulation, and we wanted to see, this is an arterial in Tucson, Arizona, and we created a simulated system. So this is not real traffic data, it's a simulated traffic data. And we wanted to see what would happen if we had a signal system that was operating, in as Philip would say, first-generation system, time-of-day system, and compare it to the operation of an adaptive system when in maybe a football game day situation. And we're talking about American football here, not English football, the one you play with your.
Oh, we're not talking about Wimbledon.
Yeah.
We're talking about Wimbledon.
Yeah, no. We're talking about American football. So,
Okay.
University of Arizona here has a big football team. But we wanted to see, or maybe there's a parking permit change. We wanted to see how a traffic condition that was unexpected would affect a first-generation system and would affect an adaptive system. So if we were looking here, this is an east-west arterial, Speedway Boulevard, and we wanted to see how both systems would respond to a traffic pattern which, say, vehicles were heading westbound on this arterial and then decided to head southbound on the westernmost intersection, which is Euclid Avenue. Right there, there's a picture there that shows Euclid Avenue as well as a big parking garage, the main gate parking structure. So you can go ahead to the next slide. Should queue up a video.
Oh,
Sometimes
nice.
it takes a second or two to load.
Yeah, we can see it.
Okay. It's a bit choppy, but it's running. Normally it runs fairly smooth. Either way, so this is the beginning of the peak hour. So this is traffic flowing as designed, right? This is the first generation system or the adaptive system, which are technically both on the same playing field at this point in time. We are just at the beginning of the peak hour. Seems like it maybe because it's running on a webcast, it's running fairly choppy.
Yeah.
Maybe. All right, either way. So this is the beginning of the peak hour, and then you can go ahead to the next slide. So 30 minutes into the simulation, and this is, if you see down there towards the bottom left corner, the time signature is 2,700 seconds. The beginning of the peak hour, we let the vehicles populate into the simulation to 900 seconds. So this is, 30 minutes after that. 2,700 seconds into the simulation, and this is the first generation system. So this is just a time-of-day optimized system. And we can see the westbound left turn is backed up past the next intersection right there, and it actually goes back to the intersection past that one. And this is because we implemented a traffic fluctuation there in which we wanted to see how both systems would respond to a westbound left turn, a large influx of westbound left turns there, heading to that parking structure that was highlighted a couple slides back. And you can go ahead to the next slide. Okay. And so here was the adaptive system. As Philip has mentioned in his verbiage, we had the first generation system and the adaptive system. In this sense, if you look, the time signature is the same, the 2,700 on the same simulation. But with the adaptive system, the system had reallocated the splits to adjust for that large amount of westbound left turn traffic. And that's why at the same time signature, the queue has effectively been dissipated. which is really nice. That is the core competency of an adaptive system, is dealing with those instant conditions, or those conditions that are not foreseen by a time-of-day plan. So we can go to the next slide. So here's just a little eye into how Centrax Adaptive does its work, which is a derivative of ACS Lite. So the way we are implementing the split adjustments is by seeing how much of the allocated green time is used. So here you can see at the bottom the phase sequencing for Tucson, Arizona. This is the phase sequencing that they're using, which is fairly interesting. It was technically a four-phase sequential operation, in which the through phases operated first, the left turns operating after that, and then the through phase and the left turn. And the left turns can operate permissively during the through phase windows. So here, over the last, let's say, 3 observations, we can see that phase number 1 was using 100% of its green time every time. And that was the problem phase, the phase that we expected to have the trouble due to the added traffic flow. So that comes at no surprise. But on the other hand, phases 3 and 7, the north and southbound left turns, in the course of the simulation, were only using, say, 10.7% or 0% of their allocated green time in this simulated traffic condition. So in typical actuated coordinated operation, the excess time from phases 3 or 7 either be gapping out or being omitted would go to the next main coordinate phase, 2-6. And in this case, that's not exactly where the time was needed. The time was needed on phases 1 and 5. So if you just click, it should bring up the phase allocation window. Okay, there it is. So at 7:48, which was that time signature, about 15 minutes into the simulation, so about halfway in between the 2 videos, the beginning of the peak hour and then the congestion condition, the adaptive system. Oh, you can go back. Okay, yeah, so the adaptive system recognized that phases 3 and 7 were underutilized, and the phases 1 and 5 were overutilized. So it takes the excess split time from the underutilized phases and gives it to the overutilized phases. So this is the as I've mentioned before, the core of what an adaptive system is doing. It's allocating the green times in order from the phases which are overutilized or underutilized, and giving it to the phases that are overutilized, and then adjust the offset to maximize progression throughout the arterial. So by continuously monitoring a traffic system and being able to respond to these instant conditions, where, say, maybe if there was an accident and a left turn does become very heavy, or maybe a through phase becomes very heavy, something becomes out of the ordinary, something that a time-of-day plan is not intended to deal with. That's where an adaptive system can really shine. And I think Philip hit the nail on the head there when he said that the benefits of the adaptive system come into play not in a typical morning peak or a typical PM peak. They really come into play with an incident condition that was not foreseen. So that's what we aim to illustrate here with this simulation. And with that, I think I'm probably just around 6 minutes.
Wonderful. Okay, let's keep going. I think Kevin's up next. Are you there, Kevin Burris?
I am there, yes. I'm handing over to the other Kevin. So thanks, Gersish. That's fantastic stuff. So next up is indeed Kevin Fayon from DKS Associates, who'll be talking about adaptive traffic signals, thinking highways web. Oh, no, that's us. Sorry. So, Kevin, if you want to take the floor away from me, that I'm sure everyone will be very pleased about. So it's over to you. Thanks very much.
Okay, thank you. Let's move on to the next slide. I'm first asking, how did we get here? And yeah, I've been working here in the US on and off since 1986, and I came from a background where adaptive operation was the norm. So it's been a long period of wondering why adaptive hasn't been picked up, and all the sorts of same thoughts that Phil mentioned earlier. So I did a presentation in 2004 to the ITE District 6 meeting, where I tried to be a little bit controversial with adaptive signals. Are we missing the boat? And kind of toned down what I really wanted to say when I said I'd be missing the boat. And for a number of years, I thought this had all fallen on deaf ears. I suggested 9 reasons why local agencies were not adopting adaptive signal control in the USA. If we go to the next slide, I've got those listed. And I included a discussion about each of these. There we go. But then after a few years, I started seeing 1 or 2 vendors and other consultants that are referring back to this article and trying to address the issues themselves or present their own answers. So these 9 items were basically, from talking to a lot of traffic engineers, I would get people saying, well, the studies aren't valid. Yes, and both Phil and Bob said the results aren't well understood. Sometimes they just weren't believed. There are a lot of misconceptions. People saying, well, the transitions will kill you, and that showed they had no understanding of what a real adaptive system would do. It won't suit my city. Well, you often hear that. My city's different. Traffic in America is different. Or it's too complicated and I haven't got enough staff to do it. Detectors are unreliable, and that goes back to Phil's question of why isn't video getting a better shot in some systems. And it reflects the reality of the very poor standard of maintenance of roads where loops are installed in many North American cities, which is not something that people in other countries have had to deal with. Often someone will say, well, I've got an existing system, I can't afford to discard it. And that reflects the fact that the people who are going to benefit from the adaptive system are not the people who are going to pay for it. All this is done at the local city level. Most of the people who use the roads running through the cities are not the people who vote and pay rates in the cities. So if we go into the next slide, we see that at least now a number of the vendors are addressing these issues in their own ways. We just heard from Gil. We've probably all seen presentations from other vendors who are trying to address the fact that those 9 things were at least the perceptions of the traffic engineers. On the one hand, me as a consultant, I'm trying to illustrate to traffic engineers that they have a misperception. On the other side, vendors are trying to address the perceptions and say, well, hey, here's how we treat that particular problem or that particular obstacle that you think you've got. We still hear stories of failed systems or systems that don't meet agencies' expectations. And when you do the research and the real surveys and find out what's happened, in many cases, the unmet expectations can be traced directly to either poorly specified expectations or poor analysis of proposals. So it comes back to the local traffic engineers who, A, are not saying to the vendor, this is what I need to get out of this system, or they're not critically analysing a vendor's proposal to see whether what the system will do is going to actually meet the expectations, the objectives that they have or that their bosses have. And very often in the past, these objectives and expectations have not been written down anywhere. So if we go to the next slide, that's why Federal Highway Administration decided to develop the Model Systems Engineering documents for ASCT. And ASCT is the acronym that they've chosen now for Adaptive Signal Control Technology. I guess everybody's got to have an acronym because adaptive means so much to so many different people. And the basis for doing this is trying to address the failure of expectations to be realized. So if we go to the next slide, the whole philosophy that FHWA is pushing, and I refer to them because they were my client. I was the principal investigator responsible for a lot of the writing that went into this, but working very closely with their resource staff and their systems engineering resource staff. If you follow a good systems engineering approach, then you will document all the stakeholders' expectations, and you will be able to define appropriate measures of success so that the expectations are clearly expressed for everyone to see, and if they're in conflict, you can agree about how to handle that before you actually go and spend the money. Then when you've got the money, you're ready to go, vendors will know exactly what they need to deliver and what measures of performance they will need to satisfy. So people like Gil will be able to go into an agency and say, okay, you've said we need to do X, Y, and Z, and here's exactly how we will do X, Y, and Z. And then, as Rick Denny often says in his presentations, by the way, it's the law if federal funds are involved. If it's adaptive signals are regarded as an ITS project and federal funds are involved, a systems engineering analysis is required for an ITS project. And this process, which is relatively easy and straightforward to do, is a very good vehicle for complying with that requirement. If we go on to the next slide. So the structured approach leads traffic engineers to success, and those traffic engineers who have used this process now have almost always said that yes, it was not too difficult, yes, it gave them much more confidence going in that not only did they clearly express their objectives to potential vendors, but they also more clearly understood the objectives of the people who were paying the money, their decision makers, city councillors, city managers. It made sure that they were all on the same wavelength as well. So they clearly, you can more clearly set out the goals and objectives and put it in the context of what the agency's general plan and transportation plans do. You can clearly set out what strategies you want to implement on your street for serving the traffic, and we've defined these in terms that are understandable to the layperson or semi-layperson. A smooth flow in a pipeline, equitably serve adjacent land uses, managed queues where you've got potential for overflow or closely spaced intersections. When you put these together and then follow the process of developing a concept of operation in which you clearly document your needs, the constraints that you have to apply in making your decisions, and clearly describe the operational scenarios, then you can write system requirements and make sure you can control your scope by not having scope creep with lots of new requirements coming in that are nice to have but don't actually meet a clearly defined and agreed need. And there's a structure there to prepare a verification plan so that when you buy a system or implement it, you've got a process that both sides understand in which you're going to verify that what you asked for is delivered. And separately, a validation plan, which is where you confirm whether or not the fully operational system achieves the goals and objectives that you have. So this provides a very nice structure. The document itself is many hundreds of pages, most of which is made up with sample statements that link descriptions of needs, descriptions of scenarios, and model system requirements. And you can pick and choose, they're linked together so that it's obvious if you've expressed a certain need and you adopt a certain strategy, then there's a certain set of system requirements that you should have. The biggest result of this has been that traffic engineers going into this purchasing process now are less likely to have the issue that we've seen many times where they say, well, okay, I bought an adaptive system to add on to the system that I have or to replace the system that I had. And I assumed that all the reporting and all the management functions that we're used to seeing in general traffic management systems would have been there. Now, it's an assumption. And if the vendor never promised to give you management functions and you didn't ask for them, then shame on you. So this helps bring to the fore all of those things that people have been forgetting to talk about and then have been disappointed because they didn't get it. So with that, I'll turn back to you guys and to continue on.
Thanks, Kevin. That's excellent stuff. Thank you very much indeed. Now, Bob, do you want to? I've got questions from the audience which Gareth's going to be reading out. I've got something I want to say actually.
Okay.
Sum up there while I gather my thoughts. I've just discovered something from an old edition of Hiding Highways that Phil said. Very hurt discussion. I need to read it. Just make sure it's
Something seems to be wrong with your mic.
Really?
Yeah, you're sounding like a Dalek, Kevin.
Oh dear. I've not done anything different. But you carry on without me, and I'll be back in a minute. You can do the summing up.
It's all that desktop publishing stuff you're running in the background trying to get the next edition out.
That's actually very true.
Okay. Kevin, where would one get a copy of the model requirements document?
It's available as a PDF to download from FHWA's website. I don't have the exact link here in front of me, but I can provide that after the session's over.
Wonderful. And I think Phil and Gertesh both showed a diagram that shows that adaptive signal control performance stays kind of steady, whereas first generation performance goes down over time. Phil, would you say that mirrors the loss of expertise that we might be experiencing in signal control in the U.S. as well?
Well, this is a subject you can get me going on, I'm afraid, Bob, but I'll make it as short as I can. Everybody's aware of most of you are probably aware of the National Signal Report Card that was produced last year, and another one that was produced 2-3 years ago. With the two report cards taken together showed very little change in terms of the practices, traffic signal control practices that exist in the United States. And subsequent to and before that, I had produced a report on traffic signal practices, which showed that 35% of the jurisdictions in the United States have never retimed their signals, never being for a period of at least 10 years or more. And there are many jurisdictions that just don't believe that a good, solid area-wide signal retiming is even appropriate. They prefer to go out and fiddle with the signal here and fiddle with the signal there in response to complaints that they receive. So, the state of the practice in the United States is quite poor, and I think that graph is accurate, that in the sense that the quality of the signal time in the United States is gradually deteriorating over time. The impact is that unfortunately we can get away with it because the public doesn't recognize this gradual deterioration, and we're just gradually lowering the bar. But I think we're going to reach a point where the public is going to rebel and is not going to stand for it anymore. And this isn't true of all jurisdictions, I would emphasize, but a goodly percentage, so probably close to half the jurisdictions are letting their timing deteriorate without any systematic upgrades to it.
Bill, do you think sorry, this is Kevin. Do you think part of that is the fact that the measure of performance that many of the local jurisdictions have is the number of times the phone rings, and if the members of the public don't know that they can do better, they're not going to call up and complain.
Yeah, I think that's absolutely true. And, as I said, we can get away with it. Now, in defense of the people that are operating signal systems, they're not exactly awash in money. And there are systems that I know of that somewhere in excess of 30% of the detectors are not working for actuated controllers. And that probably needs to be addressed first, but that's another area you can kind of get away with it. People just have to wait longer on the cross street and they tolerate it. So the objective of the report card was to try to get the public's attention. It got a lot of publicity in the papers and so forth, but nothing happened.
I'm reminded of the old the gory story in the South here that if you throw a frog in a pot of boiling water, it'll jump out, but if you put it in some cold water and turn the gas up slowly, it doesn't realize it's being cooked.
Yeah, well, I know somebody tried that with lobsters, and it was an ugly sight.
Okay, Kevin, you mentioned that we may have a couple of online questions.
Yeah, can you hear me now? Does that work now? Am I
Yep.
sounding better?
That's a lot better, yeah.
Yep.
I unplugged and replugged. Yeah, Gareth's got some questions, but Kevin Fayan has actually given us the link to the document, which is rather long, so I won't read it out. But one thing I'll pass it on to everybody. What I did want to mention, actually, was something that Phil said in his September 2010 issue of Thinking Highways, which we called Lagging Behind. Phil Tarnoff asks why the US is playing adaptive control catch-up. And Phil said at that time, so this was 2 years ago, but a survey conducted in 2003, admittedly a while ago, by the ITE, only 11% of the 114 jurisdictions in the states that responded were currently using adaptive control. So that's only 10%. Has that increased much in the last 10 years? It doesn't sound like it has.
I'll let Gil answer that. He's probably closer to it than I am, but I think it's increased a little bit, but not significantly.
Yeah, it has increased above 11%. I don't have an exact number, but I know it is above 11%. The last thing I heard was like closer to like 15, 18%.
Yeah.
Like that's not a static number. I don't know the exact value.
Yeah. But I think Phil's point was, in this age of smartphones, smart cards, and smart cars, why do traffic engineers continue to rely on a time clock, the selection of signal timing that affects the lives of millions of people every day? So a timely thing to say, Phil. And still, I mean, you wrote that 3 years ago about something that was 10 years old, and we're still talking about it now. So clearly, more work needs to be done. But Gareth has questions. So Gareth, do you want a portion? If some of the questions are sort of just for everybody, then Gareth will just ask them out loud and sort of wide. But some of the questions will be for specific speakers. So Gareth, I'll let you do that. There you go.
Okay. Yep. Thank you very much, Kevin. There's a couple of people who have asked whether the slides will be available after the webcast. The answer is yes, up to a point. I believe, Gil, you didn't want your slides sent out publicly. Is that right?
Yeah, they include videos and stuff. So
Yep.
if anyone wants my slides, they can go ahead and shoot me an email, and I can send them over too. I got to get I don't have exclusive rights to these simulation videos and everything. Like
Okay.
that, so I want to make sure we go through the right process.
That's fair enough. In which case, anyone that does want a copy of the slides, excluding Gil's, then if they just email me, I think my email address is on the invite, but it's gareth@h3bm.com. I will send them a copy of the slides, excluding Gil's. So hopefully that covers that from a couple of people. I will move on to the first question that wasn't about the slides, from Adam Moser. It says, working for an agency that tried 3 different adaptive traffic systems, the biggest issue was operation and maintenance staff, not misunderstanding use or expectations of the system, and maintenance of the extra detection was also one of the main issues. That's maybe not necessarily a question, more of a statement, but I don't know whether any of you would like to come back on that at all.
Yeah, this is Kevin Peon. I'd like to comment. We've as consultants, we've helped quite a number of agencies go through the process of deciding whether or not it's worthwhile trying adaptive operation, and how should they do it, who should they pick, etc. And you're spot on about the maintenance staff needing to be absolutely need to be part of that process right from the beginning. In the end, their cooperation and buy-in to the system can make or break the system, no matter how good it is. And we have seen examples where the engineering staff led the whole process, didn't include the technicians, and technicians were so upset and unhappy that the system was turned off and taken out. We've seen others where, by bringing the technicians into the process, they really felt that they had ownership of it, and in some cases they've gone from, don't upset my life, I like my 170 controllers, to, wow, I've now got the best thing that helps my job that I could ever have imagined. And you have to have all the stakeholders in the process to be sure that they're all going to be pulling in the same direction at the end.
Okay, thanks, Kevin.
Cool.
The next question came from Bruce Dressel, and it's, if a system is monitored and adjusted daily, is there a cost benefit to adaptive systems that would prove beneficial?
Who wants to take that one?
Well,
I'll have a go to start. If what Bruce is meaning is that somebody is doing the traffic engineering analysis every day to make sure that the system is up to date for that day's traffic, and they're doing it fast enough that as soon as they see that traffic, they've done the analysis and put new times in, then okay, you don't need adaptive, because that's what adaptive is doing. If monitoring means, well, you're just looking at it and making sure it's not screwed up, then you're not really addressing the function, which is to measure the traffic and develop signal timing and implement it immediately that is going to meet your objective function. And even if you're paying people to sit there and watch the traffic and twiddle the knobs all day long, I really don't think you could achieve the same objectives.
I'd like to add to that if I could. It's actually, in some respects, it's a complicated question because the costs are absorbed by the agency and the benefits are absorbed by the realized by the motorist. So, in terms of bottom line, the agency's expenses are almost definitely going to increase with the implementation of adaptive control, which is one of the things that's holding it back. But one of the beauties in general of signal control is you can do an awful lot with the timing and realize huge benefits and get benefit cost ratios that are far in excess of what you'd realize from most or all construction projects. And the calculations of the benefits of adaptive control have to take into account the benefits of people's time, the benefits of reduced automobile operating costs, reduced fuel consumption, improved emissions, and if those benefits are taken into account properly, you almost always will have benefit cost ratios in the order of or greater than 10 to 1.
Yeah, I'd also like to add on something you said, Phil, that is it 33% of the systems are not being retimed within 10 years. There's a case for adaptive right there. If a system's not being retimed manually, then an adaptive system would continually retime and give us the benefits.
Yeah, but one thing that I'd like to say something negative here. I'm known for that, as Kevin will verify. There's a downside to adaptive control, and the one question touched on it was the increased maintenance costs. There's also, you're not all completely off the hook in terms of maintaining a database. There are things in the adaptive system that you have to tell the system about. If lane configurations change, if there are mid-block sources or sinks that are created, there's a number of areas that the adaptive control database also has to be maintained. So I think that's one of the reasons that some agencies install these systems and are disappointed, is because they figure that they'd be able to just go turn it on, walk away from it, lock it in the closet, and forget about it, and they can't. And I think we'd be remiss if we didn't mention that during this I won't say webcast, podcast, whatever Kevin's calling it this way.
Webinar, yeah.
No, not webinar. I don't care.
Okay, if everyone's finished on that one, then I shall move on to the next question, which comes from Matthew Dew. Would an adaptive system work well under construction conditions, for example, daytime lane closures?
I like
this is Kevin. Definitely yes, if it's got detection that you can move around, so video detection, and that video detection is compatible with the system.
Well, I'd like to add also, again, if its database is kept up to date so it knows that the capacity of the roadway is changing.
Yes, and if also if it's one of the systems that keeps that still calibrates in that area.
Right.
I would also add that if the construction is a result of land development, then it would be good because perhaps the developer would pay for the cost of the system.
Huh. The entire system for the whole city?
No, the corridor around the construction. Oh, well, that's an interesting thought, though. How can we get more money for traffic signals? And, you know, there doesn't seem to be any guidelines anywhere to say how much a city should spend on average every year on its traffic signals to keep them up into good shape.
Oh, yeah, there are.
Yeah?
If you, you know, the cost of signal retiming runs about, the last number I saw was about $1,800 per intersection for signal timing, that's the complete data collection and you know, upgrading the timing and evaluation. Runs somewhere around, let's say $2,000 per intersection. And it should be done every 3 to 5 years. So that's what I'm talking about for a first generation system.
Right. But I guess, as you mentioned, Phil, that if the public reaction is just apathy and nobody's noticing, then you can get away with spending nothing for a lot longer.
And that's what's being done, exactly.
Yeah.
And I've heard agents as recently as a couple months ago say that, you know, forget about signal timing, stop nagging us about signal timing. We don't even have enough money to keep our detectors maintained. So.
Right. So, do we have to design a signal controller that will go on to flashing red if it's not been retimed after a while?
Yeah, right. Well, no, there is, but the public is getting very annoyed about it. I'm not going to take your time with the story, but there was an effort in the Washington, D.C. region to retime the signals that my name was mentioned in the Washington Post, and I was getting calls all morning at work from disgruntled citizens about the signal timing. Fortunately, I was in a good position because I wasn't responsible for anything. That's one of the benefits of being an author.
So it seems to me that what we're picking up, sorry, Gareth, we're picking up a trend that, you know, in order to increase the adoption of adaptive signal control, then, you know, maybe the people that are operating the system maybe need to be a bit more adaptive themselves.
Yeah.
Gareth, did you have another question?
I've got time for one more. I think one more question.
Okay, we've got lots more. I have to say, there's obviously quite a lot of interest in here. Since Ravi Sabi sent me at least 2 questions, I'll ask them both together, and maybe we can get an answer to both of them. The first question was, how is adaptive system advantages for near saturated intersections? And the other one was, how much would it approximately cost to implement adaptive systems per intersection?
Gurtesh, you want to pick up the one on the cost?
Yeah, I mean, as far as the saturation goes, I mean, there's a when Philip was hitting the point about managing expectations, you got to know that if we have basically we're at 100% capacity, nothing's really going to solve that problem, right? But the thing about adaptive systems that we aim to achieve is maybe pushing out the amount of time, say it's longer before the intersection reaches capacity, and maybe it alleviates that gridlock sooner, so it spends less time at capacity. That's a goal of adaptive systems. Do you want to add something to that, Bob?
Well,
no, I think you're pretty much on the go, Phil.
Okay, yeah. So the main feature of adaptive systems is going to be to mitigate the amount of time that the intersection or the arterial or the system in total is in the saturation. So we're aiming to maybe make it saturated for a less total amount of time. Therefore, that's pretty much the best we can do besides adding more lanes or anything physical. I mean, from a technology point of view, it's the best we can do. And as far as the...
Sorry, can I just add on that one of the things that we've talked about in the model systems engineering documents is that you need to have different coordination and control strategies for different conditions. And so one of the things that you need to look for in an adaptive system, if you've got a situation where you have some intersections operating at capacity, is can you go into a different strategy when you approach the capacity, such as managing the location where queues fall, and not simply just be trying to open your green band wider and wider and putting more traffic into the intersection where you've got the oversaturation problem. So there's a whole lot of different issues that you need to think about as when do you need different sorts of strategies, and then look at the available systems and decide whether they have the ability to automatically implement those different strategies when they detect those traffic conditions.
I'd like to pick up on that. Back in the 70s, there was a lot of research. When I was at Federal Highway, there was a lot of research done in that whole area of congestion control. And I think I don't know, it was Kevin who was just speaking, but he's right on in the sense that when you get to congestion, things change dramatically, and you're not just trying to maximize throughput. The conclusion of that research was that what you really want to do when you've got super congested conditions is you're basically managing real estate. You're trying to prevent the queue backups to the point where they block upstream intersections and things like that. We tried to implement some of those plans, and there are some systems today that approach that, as he said. But what's needed is better forms of detection, and now that we have some of these probe types of detection, I'm looking forward to seeing newer forms of congestion management that really can measure queues and try to service the intersections in a way that manages the queues rather than just worrying about maximizing throughput.
Well, I would also like to add that we sometimes project congestion as a big problem, which of course it is, but if you step back a little bit, congestion is a symptom of economic activity and well-being, so it's maybe a nice problem to have, especially if we just come through a bit of a recession. So maybe we should be happy to deal with a problem.
It's not a bug, it's a feature, right?
Exactly.
That's what I'm going to tell if we're working at a TMC, is that you tell someone when they're saying that there's a lot of traffic. You say, oh, say to be happy about the economic activity.
There you go. And it's, you know, you put a Wi-Fi transmitter at the intersection, it's not a red light, it's an opportunity for a download.
Okay, guys, I'm sorry we're going to have to leave it there. That hour has gone very, very quickly. So I'm sure we can, I think there's enough here for a second adaptive traffic signals webcast at some point in the near future. We'll do another one before the end of the year for definite. If you want that report or the document that Kevin mentioned earlier on, again, email Gareth at h3bm.com. We'll send you the link. But for those of you with a pen, I'll give you the brief. It's a very long link, but it's if you go to http://ops.fhwa.dot.gov/publications. That's ops.fhwa.dot.gov/publications. There's much more of a link than that. But anyway, you can...
Hey, Kevin, I see
yes.
There's another question coming up, which is, what's the cricket score?
I haven't looked. I turned the internet off. I'm not looking. The England game doesn't start till 9:30 p.m. my time, so I've not looked yet. So there will be a second one. We have one disappointed customer who said didn't cover enough of the presentation, but didn't uncover enough of the talking points. That's because there's so much to cover. So I quickly want to thank everybody.
Kevin, just before we go,
yes.
Just a couple of points. I think I would back up what you're saying about being able to do another one on this, because we do have a lot of questions and talking points. I will see whether I can, I'm not sure how this works, but if I can download these and maybe put them together, it might point us in the direction of where we can go for the next one. And one question that's just come in from Mike Young, it said, could you repeat the link, please?
Oh yes, ops.fhwa.dot.gov/publications. There's much more to it than that. If you go to that link, I'm sure you'll find it. But email gareth@h3bm.com, and Gareth will be able to send you the full 174 character link. So I'm not going to read the whole thing out. But basically, so quickly, thanks Bob McQueen. Thanks so much indeed for your usual contributions. Thank you, Bob. Thank you to Gertej. Thanks to Kevin Fayon. Thanks to Phil. And thanks to Gareth for fielding the questions. Our next Positive Thinking webcast, thank you, is on Thursday the 28th of March. It's on connected vehicles. We've got a great speaker panel. We've got Richard Bishop, a well-known authority on the subject. We've got Bryant Walker-Smith from Stanford University. We've definitely got someone from Southwest Research Institute. Haven't named them yet. We've got Alfred Tom from General Motors, and very pleased we've got Shelley Rowe, former director of ITS JPO. That starts exactly the same time as this one, 2 p.m. Eastern Time, 11 a.m. Pacific Time, whatever time it is in Australia. Sorry, I can't remember. It's 7 p.m. in the UK, but it starts at 6 p.m. in the UK, 7 p.m. mainland Europe. We've only got 2 minutes for these nice people shut.
Kevin, how many participants did we have today, Kevin?
131.
Excellent.
Which is pretty good. I'm quite pleased with that. We've got 66 left. So a lot of them have just thought, oh, I've had enough now.
Oh, right.
So
That's just over half. Oh no, now we're below half.
yeah, now we're below half. Including the disappointed person who didn't think we covered enough. But anyway, so thank you all for coming. For all those of you who attended, I hope you enjoyed it. We will cover more. We will be back later in the year with this part 2 of Adaptive Traffic Systems. Maybe the same speakers again. That'd be great. Hopefully Don Mass will be not stuck in traffic next time. But the next one, 28th of March, 2 p.m. Eastern Time, 11 a.m. Pacific Time, on connected vehicles. So hopefully you will hear us. We won't see you. That's TV people say that we'll see you. No, you won't. You will hear us in 2 weeks' time. So thank you all very much indeed, and good night. Thank you.
Thank you.
Thank you.